Hello all, and welcome to Fun with Physics Part 2 featuring physical optics and Rayleigh's criterion. Physical optics are the wave phenomena of light. It is the study of interference, diffraction, polarization, and all other phenomena that is unexplained by geometric optics. Interference refers to the idea of light waves superposing to either creating a larger, smaller, or the same amplitude. This creates light or dark spots due to the constructive and destructive effects of waves combining. Diffraction describes the phenomena of light bending around the corners of an obstacle or a slit. Polarization is the property of light waves that allows the vibrations to occur in a single plane. Rayleigh's criterion, however, isn't an optical device, but it is a criteria that determines the separation angle between two light sources in order for them to be distinguishable from one another. Lord Rayleigh was an English physicist who invented this criteria in the 19th century. He made this discovery, amongst many others, including Rayleigh scattering, and published these findings in his book that is still relevant today, titled The Theory of Sound. In order to understand this criteria, we must first understand the concept of resolution. Resolution is the degree of fineness with which an image can be recorded. It is often expressed as a number of pixels per unit of length. Diffraction plays a role in this resolution at which we can see images. At a certain point, when two light sources are too close together, the images are indistinguishable. If two light sources are close together, the image can either be unresolved, partially resolved, or fully resolved. Rayleigh's criterion states that in order for them to be distinguishable from each other, the center of one diffraction pattern has to directly overlap the first minimum of the other diffraction pattern. If they are any farther apart, they will be considered well resolved, meaning that they are easily distinguishable from one another. If the distance is any less, then they will be unresolved or indistinguishable from one another. The equation to determine the angle the objects are separated by is theta equals 1.22 lambda over aperture diameter, where theta equals the angle that the objects are separated by, lambda equaling the wavelength of the light, and d equaling the aperture of diameter. Rayleigh's criterion also has a number of real-life applications. We see it in nature, for instance, with owls. This is because the criterion says that you can see things that are smaller if your eyes are bigger. Owls have big eyes in order to scope out any small mice as their prey, and this is all stated by Rayleigh's criterion. Additionally, the criterion states that if you widen your pupils, increasing the aperture diameter, as humans do when it gets dark to take in more light, we see things with a smaller angular size and they take up less space on your retina, so we can see them better. Also, if people look at something with bigger wavelength, it takes up more space on your retina, so if you're looking at a blue image, for instance, you can see it slightly better than a red image. Well, thank you all for watching. Hope you learned a lot about Rayleigh's criterion and physical optics, and remember kids, physics is fun, drugs are bad, stay in school.